Tim. The Vision Group's latest product is extending the power of LabVIEW into embedded, distributed vision applications.
That sounds like a smart camera.
Well, not quite. As you might guess, we've taken a different approach, a distributed, flexible system approach. Recently, National Instruments released the NI-CVS 1454 Compact Vision System. We're really excited about the Compact Vision System because it simplifies machine vision, making image processing accessible to new customers and new application areas. The traditional smart camera approach combines an image sensor with basic image processing, but it falls short of providing all the capabilities actually required on today's factory floor. As this chart shows, the Compact Vision System actually has more functionality than 3 traditional smart cameras. And like the Compact Field Point Unit shown up here earlier, it was designed to be extremely rugged, and it can take a lot of punishment. It has no moving parts and can withstand temperatures from 0 to 55 degrees Celsius. The Compact Vision System also delivers high performance far beyond traditional smart cameras. It also features advanced digital I/O, supports high frame rates, and connects to multiple cameras. The Compact Vision System integrates the technology of our Vision Builder for Automated Inspection, LabVIEW Real-Time, and LabVIEW FPGA products, and combines those technologies with feedback from our machine vision customers to create a powerful new vision platform. Let's take a look at an example application that shows how the Compact Vision System is extending the power of LabVIEW and virtual instrumentation into machine vision applications. For this demo, we're interested in inspecting spark plugs as they come off a manufacturing line. To simulate this, we have a turntable with spark plugs rotating at a rate of about 10 spark plugs per second. And to make this measurement, we're actually going to acquire an image and then use image processing running here on the Compact Vision System to find the edges of the spark plug and measure the gap between the top of the spark plug and the electrode. The size of this gap is actually important to ensure maximum effectiveness from the spark plug. As the spark plug comes in front of the camera here, we have a proximity sensor which detects the presence of the spark plug and triggers both the Compact Vision System and the camera to acquire the image. The Compact Vision System then uses LabVIEW Real-Time and iMac Vision to actually process the image and find what is actually coming out. What we're using here is a 1394 camera connected to the Compact Vision System.
Okay. So why did we choose 1394?
Well, one of the drawbacks of traditional smart cameras is that the vendor defines the sensor, forcing the customer to choose from a limited selection of resolutions and frame rates. There are, however, a large variety of 1394 cameras available on the market today, and we expect that number to continue to grow over the next few years. By connecting to any industrial 1394 camera, the Compact Vision System gives the user the flexibility to choose the right camera for their application. For example, they could choose a lightweight remote camera for an industrial application, or a high-resolution camera for gauging small objects, or maybe even throw in a low-cost monochrome camera for optical character recognition, all on the same product. And the best part is that if application needs changed, the camera can simply be swapped out. So for this application, we actually chose a small camera capable of triggering at high frame rates. And you can see the result of the inspection up here on the slide. What we're showing is not only the actual acquired image, but also the results of the inspection, the gap measurement, and the individual pass-fail result for the product. This application was developed using our Vision Builder for Automated Inspection product. This product is our configurable environment for interactively developing machine vision applications. We then had it actually generate the LabVIEW diagram that we're using here up on stage that is running in the Compact Vision System to do this inspection.
Now, we could have stopped here, but this really doesn't show off the full functionality of the Compact Vision System. So we decided to add an additional requirement to check that the spark plugs actually spark. To do this, we added a 40,000 volt ignition coil to the demo.
40,000 volts.
Yeah, we had to make it a little dangerous, you know.
40.
The Compact Vision System sends a digital pulse to the ignition coil, which ignites the spark plugs as they pass by the coil connectors. Now, in order to measure the spark, as well as continue to measure the gap that Anita talked about earlier, we're going to need to add a second camera because the brightness of the spark is actually going to obscure our gap measurement. Fortunately, the Compact Vision system connects directly to up to 3 1394 cameras. By having a second camera, we can inspect the spark plug in 2 different locations, one to measure the spark and one to measure the gap, and we don't have to purchase and set up a second system. The second camera is mounted a fixed distance away from the first camera. The Compact Vision system uses a quadrature encoder input from the turntable to acquire an image of the spark plug just as it passes in front of the second camera. The Compact Vision system triggers both the ignition coil and the camera, igniting the spark plug at the exact moment that it passes in front of the second camera. Now we can switch the video output of the Compact Vision system to our second camera, and you can actually see the images of the sparks here besides the gap measurements to show that we're making 2 measurements. Now, because the Compact Vision system is using a quadrature encoder input to trigger both the camera and the coil, we can speed up and slow down the motor, and we're still able to precisely acquire and trigger the spark plugs in the same location. If Anita turns up the motor to its maximum speed, you can see that the Compact Vision system is still able to make the same measurements.
Yeah.
In this case, it looks like the Compact Vision system is acquiring and processing over 22 parts or 44 images per second. That high-speed measurement and triggering capability is something that's not possible with traditional smart cameras.
Wow, so you've brought up quite a few features. I bet you want to tell us about a few more.
Yeah, I'd love to, Tim.
Okay, yeah.
In addition to being a LabVIEW real-time target and offering direct connectivity to up to 3 1394 cameras, the Compact Vision system has 29 digital I/O lines, as well as a VGA video output. In fact, when you purchase a Compact Vision system, you can take it out of the box, connect it to a camera, monitor, and power supply, and immediately begin seeing live acquired images. And once you've acquired and processed those images, you can use the Compact Vision system's Ethernet and serial ports to communicate with other distributed measurement nodes, such as PCs, PXI systems, compact field point modules, or other Compact Vision systems. And oh, by the way, Tim, the Compact Vision system's timing, triggering, and digital I/O capabilities were all developed using LabVIEW FPGA. Wow. So in a sense, the Compact Vision system was one of the first customers of LabVIEW FPGA. Great. In future versions of the Compact Vision system, users will be able to use LabVIEW FPGA to customize the hardware, allowing them to solve an even larger variety of complex tasks.
Fantastic. Thank you, Anita. Thank you, Evan.
Thanks,